Find average values of following. I'm plotting 2, 3 graphs. You have to find out average value of all each of these. Number 1, number 2, number 3. What is the average value of current in these cases? Up to time t.
The second one, I naught, sir.
Which one is I naught? So this is easiest. If the current is same current, constant current.
Second one.
Second one will be I naught because it is constant current. So it will be I naught, correct only.
First one is tan theta into t by 2, sir.
I2 average is I naught. First one is also, I think, not tough, huh?
Tan theta into t by 2.
Linear graph, straight line graph. For straight line graphs, always average formula is, what is the average formula for straight line graphs? Let me
First plus
give an-
last by 2.
Yes. First plus last by 2. That is an example. First plus last by 2. That is for linear graphs. Only for linear. Not applicable for curvilinear graphs. For example, in this case, if I want to take here, it will be I first plus I last divided by 2. But in our for example, it will be just this is here. Up to what time? Up to the time for which I have given the values up to this time. Up to t time. Hmm. 0 to t naught. Let me give it just t naught time. 0 to t naught time. Okay. This is new I versus t. And this here I1, as you said right already, it is 0 plus
Tan theta into t by 2.
t tan theta
Tan theta by 2.
by 2, right? Because the value is at time t. This value is here t tan theta, right only. Recording started or not?
Sir, I have started.
Okay. T tan theta by 2, right? This is I1. What about I3?
Sir,
This
I three is sine function only, no, sir.
Sine function. For sine functions, I want to say something. The average values of the sine functions remains same if we are in any, for each quadrant, average value remains same. Maybe if somebody is asking up to, let me tell you this thing. Wait, if I'm asking up to this part, or in this part, or in this part, or this part, you understand that average is nothing but it is integral I dt upon dt. So what is numerator? Numerator is nothing but area, and it is understandable that area will remain same for which regions. If I divide into this quarter parts, each quadrant part has same area. This part, first quadrant area, and the second quadrant area is same. Is the same or not? First area and the second area, but these are not same as third and fourth will be negative areas. These two will be negative ones and equal. These will keep cancelling the areas of the first and the second one. What is area of each quadrant? If we remember that, then it will be helpful for us to find out average at any instant of time. IT. So I will find the area mainly for the first quadrant first.
1 minus root 2 by 2. 1 by root 2.
This I can say first quadrant is up to what I have to integrate.
5
I
by
have to
4.
get t by 4. Time by 4. If I give it in terms of omega, then I know t is equal to 2 pi by omega. So I can also call it as in terms of omega, it will become, I think, t by 4 is pi by 2 divided by omega. Up to that, I have to integrate. So let its equation be I is equal to I naught sine omega t. What is I into dt integral? That will become I naught into sine omega t dt integral 0 to t by 4. What would that be? What is that? I naught into
I
cos
naught
omega
into
t.
1 minus cos omega capital T by 4, sir.
Which is equal to
I naught into 1 minus cos omega capital T by 4.
So divided by omega will watch.
Yes, sir,
omega will be,
divided by omega.
Divided by omega,
Divided
sir.
by omega.
and inside will be 1 minus cos of omega into t by 4. What is cos omega t by 4? I think you know it would be 0 because cos omega t is pi 2 pi. Omega into time period is 2 pi. So 2 pi by 4 will be pi by 2. 1 minus 0.
I not by omega.
Simply I naught by omega. That is numerator. And that is area under one quadrant. Area of each quadrant. We have, it is useful to remember this area of each quadrant. Okay. Then I know what is average value of I3. I3 average will become then what would it be?
2 I not by pi.
I naught divided by omega into t by 4, right? Numerator divided by denominator. This will become equal to, as we said, 2 I naught divided by pi. So we can remember this average values.
Sir,
Yes.
by integral dt only, no, sir?
By integral dt only.
Yes, sir. Okay.
Is equal to this was numerator we have already derived here, 0 to t by 4, 0 to t by 4 I dt divided by 0 to t by 4 dt. This only. That's why we are getting I naught upon omega t by 4. So I3 equals, if you want to remember, you can remember in this way also that it is peak value divided by pi by 2. That is average. Understood? What is average? I naught divided by pi by 2 or I 2 or I naught by pi. However way you want to remember it. But this is something which I have learned, and I learned very few things. So I think it is important for you to know that this should be learned by us. This average value of, because in this chapter we will be dealing with which currents? Sinusoidal currents, mainly AC. So we should know this average value. It is important for us. We should remember it. Have you learned or no? Learn it now only. Have I lost you?
No, sir.
Okay, right. Then next, in this question only, for sinusoidal only, we have another case also possible. If I don't ask for this time, but I ask for, let us say, 2 quadrants. What will be the answer for 2 quadrants?
0.
Average. No. 2 quadrants I'm saying. First 2 quadrants.
Adding, sir, one I
Same,
naught
sir,
pi
same.
by 2 plus I
It
naught
will
by
be same ultimately. Why?
Same, sir,
Because
same.
area will become doubled. Area of this and area of this is 2a, 2 times area. But also time will also be, it is t by 4, it is t by 2. Time will also be 2 times
Time will also
t
be
by
doubled.
4. Time will also be doubled, and each area we know is separately equal to, I think, I naught divided by omega. So it is becoming finally I naught divided by omega upon t by 4 once again. Same thing only again, because 2 and 2 is cancelled. Okay. This I'm saying 0 to t by 2 I dt. So again, same result. I naught divided by pi by 2 or 2 I naught by pi. Same as before. Now let me take 3 areas. 3 areas means
Then one will be
0
cancelled,
to
sir.
t, what is this 3, what it will be? 3t by 4. Yes, this area will be negative, it will be minus. Correct only. It will also be minus. So to 3t by 4 I dt will become 2a minus a divided by, time will not cancel, time will increase only, 3t by 4. This will now become I naught by omega divided by what?
3 times of t by 4.
3 times of t by 4. Which should become
2 I naught by 3 pi.
2 I naught by 3 pi. What is that? This is I versus t graph. This is average. Okay. I'm keeping it here itself. This is average up to. So you can find out now average for any interval provided this area you remember. Then provided the intervals are of means some integral multiple of these quadrants. If I ask you for 7 quadrant, what will be that? 7 quadrants starting with. It depends also how we start. For example, if I ask for cosine graph, you can find for the cosine also. I versus t. If I start in this way, this way, this way, this way. What is average value up to this? So we can check how many areas. First you count numbers. These are cancelling. This part is cancelling each other. What is uncancelled part? This is uncancelled part area. So what we are getting, I naught by omega divide by what is the time total? T by 4, and how many terms? 1, 2, 3, 4, 5 terms. 5 into T by 4.
5 T by 4.
What is average? And average is coming out to be I naught upon 5, and here 4, and here it is omega into T. Then it is becoming I naught upon 2, 5 into pi, I think, right?
Yes, sir. Yes, sir.
That only, that is I average. So we can find I average for any case, but the cases which we can't find from that. If it is very long time, they are sometimes they ask average value without telling the time. When they ask average value without telling the time, it means they are asking for very long time. What will be the average value for very long time? For very long time, it will always be considered 0. Reason, time will become infinite.
1 by infinite 0. Yes.
Denominator will become infinite, but numerator will be something, and that something may be finite value, but I don't care, because when the denominator has become infinite, numerator will be just finite value.
0.
Will it be finite or not? Why numerator will be finite? The maximum possible value for the numerator will be when we have two areas uncancelled. Then also 2 areas uncancelled will also be maximum possible equal to 2I naught by omega. But denominator is t tends to infinity, then this whole term will be 0. Therefore, I can say that I
So that
average
value tends to 0. No?
0 only, it tends to 0. Okay, fine. You are saying as if you are always so much accurate in physics that you need really to say, yes, I agree, it tends to 0, but we can call it 0. Means what 0? How many zeros you have to put in order to give the answer? I don't know. There will be infinite such zeros. After that, you will be putting some digit maybe. Not to think that it is 0 only. We don't care. Means why are you are, although what you said is right, but tends to 0 gives us a feeling that we have to be careful and we should not probably call it 0. Nothing like that. It's 0 only. Okay. Understood?
Yes,
Now,
sir, yes, sir.
and this is I versus T again, and over long time. Okay, so long time average, I am writing directly. Long time average. Long time average. Sorry. Long time average current. Sinusoidal. Sinusoidal means it could be cosine also. Sinusoidal currents will be 0 always. Okay. I can ask you another question here now. If I don't give initial phase to be, even if I give this way also, initial phase is not 0. It is something I naught sine phi here. Initial phase is phi, and it is I naught, and it is minus I naught. Even then also it is applicable. Don't think that it is now uncancelled. Otherwise also I have said maximum possible uncancelled area will be always maybe 2I naught. Or maybe even if it is not 2I naught, it will be some finite value, whatever. Maybe I can cancel, not cancel here, not cancel here. But then also we know it will be 0 only ultimately over a long time. Okay, next. It will be finite if I ask you this question now. How to answer this one? This is I, this is T. What is this area up to time, which is T by 4, and this is before that, any time before that? How will you find up to that? 0
Average
to
current, sir.
0 to T I dt. Find average now.
At any instant, this is average only, sir. Same.
No, not same. What same? We have to find only up to this area now, up to time T. I'm asking to find average up to time T, which is less than T by 4. Then method is same. I naught into sine omega t, limits will change only into dt integral 0 to t
Sir, I naught 1 of cos 1 minus cos omega t by omega t.
what is I naught?
I naught of 1 minus cos omega t by omega t, sir.
Cos omega t 1 minus cos omega t
By
by
t.
omega t by omega t. This is I average, right? Now we can get the answer for this step because t is given to us. So this is answer. In fact, if t is given, then we will just put that value of t and we will get value. So this average will be different from the formula which we have learned. But that formula is important. Which formula is important? 2I naught by 5. Okay. That formula is important. Another case I can ask now, shifted sinusoidal current. Shifted sinusoidal current means something like this. What is average value for this?
Will be checked, sir. No,
That initially what we found plus that triangle we can add, a rectangle we can add.
it won't be 0 yet.
I'm saying long time average. Just it is mentioned, not mentioned up to what time. Find average current. Find average current. So in this case, average current will be simply, we know what is the total area. This area will cancel this area. This will cancel this. If I take this middle line here, then that area will be that effective area or not? This will be the
Oh.
total area. So simple. I
Yes,
can tell
sir.
that 2I naught. 2I naught will be the answer. Because area under which graph it is same as this. Area under the sinusoidal graph. Area under the curve. If I take this way, this area is equal to this red area. Okay. This area.
SRS.
Because this red which is going downward, that is cancelling the red which is going out of this area. Ultimately, total is same. These areas are equal. Therefore, the average will be same as. And I have not given time. It means I'm taking long time average. For long time average, we can just take this only. We can. There is no uncancelled part for long time average. Next. Now, similarly, can you find for parabola or other? For example, let me give I as some constant k into t raised to n. How to find average? You know how to find.
Sir, we have completed areas, sir. We have completed areas, sir. Just give it to us, sir.
It is done already, right? We can do it now. So all such cases means there could be obviously infinite other cases, infinite other functions, and we don't need to learn the values of all those, but we need to definitely learn the value of sinusoidal. Okay, that we need to learn. This one I have not learned, although this one I have learned long this 2I naught by pi value over each quadrant. This value we can find from that only. Okay. RMS values similarly. RMS is also important for all these cases. One more thing, wait a second. Average of how will you find average of multiple currents? If I is given as I1t plus I2t plus so on, I3t, then I average will be equal to, I think, I1 average
Average of each, sir.
plus I2 average plus I3 average. Is it right or not?
Yes, sir.
It will be average of each over the given time interval, then they will get the net average. Okay. So average of each is equal to average of total is equal to sum of each average of each. with proper sign, but some of these may cancel each other. If one, for example, one country remains negative, other stays positive, then they may cancel each other. Okay, so if I have multiple, for example, if I have I naught sine omega t by 2 plus I1 sine omega t by 2 plus I2 cos omega t by 2. What is the average of this? Over long time. What is long time average? Don't write t, y, and don't write it. Similarly, dot dot dot. What is the average of this?
Up to time t, sir.
Up to time t. Long time average. When I don't mention time, then it is long time average, not up to time t. Then it is long time average. Up to infinite time.
0, sir.
No, yes, 0 only, because it is sinus fact only. Right. Right, answer is 0. Okay. And if I ask up to time t, then what would you do?
I naught by omega t of 1 minus sigma.
No, we
Cos
don't do
omega.
that. Wait. We don't do that. That will be complicated. I know what you are doing now. Don't do that. Just take first phasor diagram. Oh, this another phase. Then third phase. How many are there? That many. Phi 1, phi 2. First you write it in term of single current, single resultant current, and that a single effective phase. And this will change into I net I into sine of omega t plus phi effective. This is I. Once you convert into this form, then you do the integration part. Don't do otherwise. Understood? This is I naught, I1, I2, and dot dot dot. Yeah, that's it. There are other terms also. So this way I'm saying it. Some other terms are also there. Okay. And this is the final one. IN. Okay. Phi n. This is how we get the. And what is phi here? Phi will be nothing but sum of all these y-axis terms and sum of all x-axis terms. If I take numerator is y-axis terms and denominator is x-axis terms, adding all x-axis terms, that will give us 10 phi. 10 phi is equal to sigma I sine phi I and upon sigma I cos phi I. Okay. Phasors we have to use to get the resultant. And if with this any DC term is added, DC term is constant term. For example, I can say 2 amperes plus all this. Then that 2 will be added as it is here. That will not be superimposed with this. It will not create any trouble for us. Okay. All right. Next. RMS values.
Sir, once more to previous.
Yes. Okay.
Yes, sir.
RMS values. RMS values starting from our first simple case. Okay. Starting with simple case of maybe this current, and again what about this one, and what about third case, that is sinusoidal or parabola, or all these cases we will do. But these are important ones first. Three cases: I versus T graph, and this is your I naught, let us say, and this is, let us say, theta. We have to find out up to what time. Find out maybe up to maybe I can take one quadrant. I can take, if I'm able to find up to first quadrant, then if I have integral multiple of quadrants, then the RMS value will remain same, because RMS value involves squares. You know that or not? Because it involves squares, so therefore the RMS value up to this, or up to this, or up to this, or up to this, as long as we are in integral multiple of these quadrants, the RMS value will remain same. Okay.
Up increasing, down increasing will cancel out.
No, nothing is cancelling. That you do not listen. RMS means squared up.
Yes, sir, squared
I
up only,
square
sir.
into dt integral. If I square I square into dt integral, when I take square of this
Then
term
it will
also, it will also be
become
positive.
positive, sir.
It will also be positive only. There is no negative term in this. Okay.
Okay.
Now, tell me what is for first case. First case, you can write I as k into t, where k will be tan theta. I1 will be nothing but t into tan theta. I think y is equal to mx. I could have added c here. I will add that also maybe in the next. T tan theta. What is average for this case? Average formula is RMS. Sorry, RMS formula is I square dt integral upon 0 to t, 0 to t. What is that? Find it out yourself. Find all these cases yourself. In fact, I have told you the formula, and I want to do something else here. You just find out by that time. What do you have to take?
Sir, for
I1 here.
first quadrant, sir.
I1. There is nothing for quadrant here. Means for this we can find for t time. For 2 we can find for t time. For last case you just find for one quadrant, and I will tell you that the same will be for two quadrants. Same will be for
Okay.
3. Same will be for 4. But same will not be for a part of a quadrant. If I have a fraction of a quadrant, then it will not be same. As long as I am in integral multiple of quadrants, or as long as I am in over a long time, then RMS values will remain same, because in long time I can cancel. I can assume that part to be negligible, which is uncancelled. Over long time I can assume it to be same as integral multiple of quadrants. So I have to find for one quadrant only. One quadrant is more important for us. Okay.
Sir, I1 is kt by root 3, sir.
I1 is coming out to be, after solving, what is k? This is k.
K is tan theta, sir.
K into k square into t square into dt integral upon k into, no, not k,
K won't be, sir, only dt, sir.
only t, and 0 to t, and this is becoming k square into t cube by 3 upon t under the root, which is, I think, kt can be
kt by root 3.
k into t by that is
Root
I,
3, sir.
that is IRMS, right? Only. Similarly, for the second case is easiest, DC. DC means
I
constant
not,
value.
sir. I not.
IRMS in this case is equal to I not only. Second case, case 2, I2 RMS. Okay, then I3 RMS. I naught
By
d
root.
square omega t into dt 0 to t divided by 0 to t means t by 4, 0 to t by 4 dt for each current only I want to find. What will be that? I not taken common into 1 minus cos 2 omega t into dt 0 to t by 4 upon t by 4
Sir, I not square alpha.
By 2, sir, there 1 minus cos 2 omega by 2.
by 2 also there. What is it at last? Solve it and tell me the answer. I'm just by the time let me draw something.
It's getting I naught by root 2, sir. Sir,
Huh?
it's getting I naught by root 2, sir.
Okay, right only. That is exactly right. I not by root 2.
Yes,
I not
sir.
taken out. I not taken out divided by root 2 also taken out. Inside we are left with t by 4 divided by t by 4 minus second term will give us 0 integral. Integral of cos 2 omega t will be 0. Why is it 0? See, what is the integral of cos 2 omega t? Okay, let me do one thing. Let me write the integral properly. Minus sine 2 omega t divided by 2 omega and limits 0 to t by 4. This way, that is I3 RMS. What is that finally? That is ultimately t by 4 minus. So 0 only I think because of 2 omega t by 4 is nothing but 2 into 2 4 pi by pi only, and sin pi is 0 upon t by 4 under the root, and outside it is I naught by root 2. I3 RMS is equal to I naught by root 2. So it is important for us to remember again one more formula, that for sinusoidal currents long time average is also the same. Long time average of sinusoidal currents. It is sinusoidal or cosinusoidal for all these cases. It will be just same as that for each current, that is I naught by root 2.
It's long time RMS, sir.
Oh, you're right. Long time RMS of sinusoidal currents. Long time RMS of sinusoidal currents will also be I naught by root 2. And important to be learned. Okay. Learn it. Find this one, RMS for this case.
Sir,
Yes.
K into
Not
T1
K is not given. I1 and I2 are given and T1 and T2 are given.
Yes,
Answer
sir, I
should
will
be in
say
this.
K also I will say, sir.
No, don't say K. Just get the answer in terms of I1 and I2 and tell me finally what is the answer.
Sir, I2 minus I1 by root over T2 minus T1 into 1 by root 3.
Say it again. I2.
I2 minus I1 by root 3 of T2 minus T1.
Denominator T2.
Denominator only, whole root 3
Root-
into
wait,
T2
listen.
minus
T2 minus C1.
root upon that also. Sir.
That only?
Yes, sir.
No, not like that. Wrong, I think. Let me check. So I can write y I1 as I1 is equal to mx plus c. C some constant. What is the I square dt? I square dt will be equal to
Yes, sir. That's not correct,
mt
sir. It will
plus
be
c
different.
square. That's why I said mtc square plus into dt, and here it is 0 to t. What would it be now? M square into t cube by 3 plus c square plus into t, I think, plus 2mc into t. Wait a second. I think I should take one step at a time, otherwise there will be confusion. See. This integral 0 to t whole into d. What we get now? We get m square into t cube by 3 plus c square into t plus 2mc into t square by 2, 0 to t integral. What does it mean? It is m square by 3 into t cube plus mc into t square plus c square into t. This is our value of integral. What next? Next is I have to take the values. In terms of T1, T2. Not 0 to T, sorry. It was T1 to T2, right? Not 0 to T. It was from T1 to T. If I shift this here, will the RMS value change? Tell me. And I take limit from 0 to T2 minus T1. Will it still be same or not?
Yes, sir. Area
Because
same, I square area is
yeah,
same.
everything I square area and I square versus C graph will be same. So it will be same. Limits I have to change from 0 to T2 minus T1. And I can still write the same equation, but only advantage of this is I get the value of C directly now. What is the value of C? C is nothing but I1.
I1.
And limits also will become easy. I don't have to take T1 to T. I have to take 0 to
0 to
T2 minus T1. Okay, we can do that. It will be same thing. So then I can say, what should I say now? How to tell you this thing that it will be same as. So I will mention that I can shift it this way, and this limit will be changed to this. And now equation of I will become m into t plus I1. Okay. This area, if I find 0 to t 2 minus t1, then I have to just write mt plus I1 square into dt, which will become same, just c is replaced by I1. Remaining all terms same. And m, we know m is easy to find here. M is nothing but, in that was same as before also. I2 minus I1 upon T2 minus 1. Anyway, what is it now? I'm just taking this value, keeping it here. Excuse me. Keeping it here. What do we get now? I1 square. What is it equal to? M square into T2 cube minus T1 cube by 3 plus M into I1 into T2 square minus T1 square plus I1 square into T2 minus T1. This is numerator part. What will be average value? RMS value. RMS will be this numerator part divided by denominator part. Denominator also 0 to T2 1. Yes.
The T2 minus T1 whole square and T2 minus T1 whole cube, no, sir?
Yes, wait a second. What am I doing here? Sorry.
Sir, when you shift the graph, y-intercept also changes.
Yes. This is how. When I shift the
Also,
graph,
y-intercept is not same, sir.
yes, y-intercept is not same. I know that. Why did not say y-intercept is same? T1 minus T2 minus T1 square, sorry, cube. And this is here T2 minus T1 square, and this is T2 minus T1. This, what is IRMS? IRMS will be M square into T2 minus T1 cube upon 3 into T2 minus T1 plus M into I1 into T2 minus T1 square upon T2 minus T1 plus I1 square into T2 minus T1 upon T2 minus T1. Now we are getting M by 3 into T2 minus T1 square plus M into I1 into T2 minus T1 plus I1 square. You already know what is T2 minus T1. What is
Sir,
M?
it is IRMS root.
It is a root of this is IRMS. It is IRMS square. Okay, IRMS square. What is it now? M was equal to I2 minus I1 upon T2 minus T1. So upon 3 into T2 minus T1, I think, right? M square it is. That is squared up.
Cancel.
Plus, and then M into I1, M into T2 and C1 again. I1 into I2 minus I1, I think, plus I1 square, right? Have I forgotten to write T square by 2 here? Or?
2 MC, sir. 2 MC.
It was 2 MC. Okay, okay. Okay, that 2 is
Cancelled
cancelled
out.
and that is
sir.
cancelled, right? Then you tell me now what is this value finally? Solving it, we get what value?
Root over I2 minus I1 into T2 minus T1 plus 3I1 I2 by 3.
No. There is no T2 minus T1. It is already cancelled. You are again bringing it back. Just open it up now. Open this I2 square plus I1 square minus 2I1 I2 plus 3 times I1 I2 minus 3 times I1 square plus 3 times I1 square. I think here again divide by 3. What is that? That
7
is
I1
I1
square
square
by 3.
plus I2 square plus.
Sir,
Yes.
yes. 7 I1 square by 3 minus.
How 7? I don't
Yes,
know what
I1,
that
I2.
upon 3. That is I RMS square. So what is it finally? It is becoming I1 square plus I2 square plus root of I1 I2 square upon root 3. This in the root. That is I RMS. For the linear, we can find out I RMS in this way. Why I'm writing it as root of I1 I2? It is your choice. You can write I1 I2 also, no problem. Okay. It is just like geometric mean of I1 and I2. I1 square plus I2 square plus geometric mean of I1 I2 square whole under the root and divide by root 3. That is IRMS. Okay.
Yes.
Right. I think I unnecessarily shifted it. If you can, I could have got this answer here also. It will be not difficult. T2 cube, but somewhat more complicated because C value will be different here, and I have to determine C value.
C value is more complicated.
In this case, C value will be more complicated to determine. So therefore, I shifted to the new graph so that the C value is easy and it is just I1. But in this old case, C value will be more complicated. Okay. Just to determine C value, I shifted it. And I know that answer will be finally same only. Okay. And it is easy also now, not difficult. I think I1 square plus I2 square plus. In fact, what happens if I take in general, let us I take a graph which is quadratic. And again, I say it is going from I1 to parabola graph or something which has quadratic terms. And I want to find for this. Then again, I can find in the same way. It will become, I think in that case, I1 square plus I2 square plus I1. Something happens, very beautiful pattern we get now. I'm not remembering exactly. I1 into I2. I1 raised to power, I think. Okay, I'm not remembering right now, just leave it. But we can get this in general in terms of I1 and I2, even for higher order terms also. Not needed, not required for you. They don't ask also, but I have once found myself only. Anyway, this is IRMS for such cases, and most important of these cases were again sinusoidal values, because this is what we are dealing mainly. So this we should remember. What is average value of a sinusoidal current over one quadrant? 2I0 by pi. What is average value of sinusoidal current over long time? Long time is 0. Is it right? Long time is 0. All right. Next. How to find out the average, RMS when we have multiple terms like I0 plus I1 sine omega 1t plus I2 sine omega 2t and so on. Omega 1 is not equal to omega 2 is not equal to omega 3. None of these are equal. Okay. and this is I. What is the IRMS value now? IRMS value we can find as I naught square plus I1 by root 2 is RMS for the second square plus third has RMS I2 by root 2, that is also squared up, and so on, whole under the root. This is what RMS value is finally, effective RMS value. Okay. Can you prove it?
Yes, sir. By dividing integration, we can get this.
How to prove it? Proving is not tough. It is I1 square sine square omega 1 t term plus I2 square sine square omega 2 t term, and it is I naught square plus product terms. Product terms will be I1 into I2 into sine of omega 1 t into sine omega 2 t. Now let me tell you what happens to the product and what happens to the remaining. This is numerator part, okay? Numerator square of numerator part. So we know this will remain as it is. Nothing happens. It is I naught square into t for this part. For this part, we have already calculated I naught by root 2. For this part also we calculated I2 by root 2. I have to just prove that the product terms will give us zero value. How do we know product terms will give us zero value? This product can be written in terms of omega 1 plus omega 2 sine of a plus b into t, and cos of a plus b, a minus b into t, in these terms, omega 1 minus omega 2 into t, right or not?
Yes, sir.
Yes, sir.
Right. So what would be what is it here? Anyway, for this particular example, if it is sine a sine b, it is here cos of omega 1 plus omega 2 t, and plus or minus
Minus cos omega 1 plus omega 2 into t plus cos
minus minus cos of this one.
Sir, here plus opposite. Yes, sir.
Yes, sir.
Cos of a plus b. Cos of a plus b is cos a. Cos of a minus b is cos a cos b minus sin a sin b. Right or not? Cos of a minus b.
Plus.
Plus, sir,
Huh?
middle.
Cos of a
Oh.
minus b is cos a cos b plus sin a sin b,
Plus
and cos
sin
of
A
a
sin
plus b. Okay, okay. Cos of a plus b is all right. Then by that we are getting this. Then next, this term and this term will be zero or not? On integrating, limits putting 0 to t and long time average, t tends to infinity. Then this is finite value upon infinite value. This will give us zero long time average, right? Zero long time average. What
Yes,
about
sir.
these values? These are not giving us zero long time average. Why not? Because in this case it is I naught square into t upon t. T and t
The
cancel.
constant term will be.
So these terms are not, these long time averages will not be zero. This will be this long time RMS values, but its long time RMS value of this product terms will be zero only. So therefore we know that finally we will be getting IRMS as this. Valid only for which cases? When omega 1 is not equal to omega 2, not equal to omega 3. Why? If omega 1 becomes equal to omega 2, you notice here, then this term is cos 0, that is 1 only. Then we have some other constant terms coming here. We can't simply do it in this way. Okay. So this method is valid only when all omegas are different. Every omega should be different. Then we can do it in this easy way. And there should not be any other term, like only DC and sinusoidal terms, but no such KT term, etc. That again will be somewhat more much more complicated. Why? Because that KT will have product with I naught, with this, and that will be very, very complicated. We cannot determine easily. If there are just 2-3 terms, then we can determine, but we cannot generalize that. We cannot generalize it. And we can generalize one more thing. If I is equal to I naught plus I1 sine omega t plus I2 sine 2 omega t plus so on. Now you understand what is the pattern now? These are multiples of each other. Plus I3 sine 3. No, not that. I wait. Sorry. Again, this is same as before. If omegas are different, then same as before. But I'm not taking omega same. I'm taking omega different. Now omega same I'm taking, but I'm taking phase is different. Plus phi 1, plus phi 2, plus phi 3, and so on. How to do this one? This is one separate term. These are separately. These we can take like take vector sum. Take vector sum or phasor sum. And you know how to take the phasor sum, right? This one, this method. Have you understood it?
Yes, sir.
First phi 1, then phi 2, then phi 3, and so on. Let us take it phi 1, phi 2, phi 3, and how to get the resultant. Just take it like vector, take its I cap component and j cap component, I cap, j cap, and add all those I cap components. I'll add all those j cap components I will be getting. Means it will be sigma I along y axis, I, or let me write kth component, I k along y plus along j cap plus sigma I k along x I cap. That is effective I vector. Once I know the effective I vector, take its magnitude. Its magnitude will become I k x sigma I k x whole square plus sigma I k y whole square under the root. That is net magnitude of this vector. And phase, some new phase will come here. What will be that new phase? Some unknown phase. We can determine that unknown phase by suitable phi n. This is total phi. How to get that phi n? Tan phi will be equal to sigma I k y upon sigma I k x. Right? Understood? K varies from 1 to n. K varies from 1 to n if there are n such terms. So we can get it in same way, in the normal way, and this whole will be reduced to single term. So there are two terms now. What are those two terms? Those two terms are I is equal to I naught plus I effective into sine omega t plus phi. And what is RMS for this? As you know already, I is not square plus I by root 2 square under the root. That is it. Is it right? Yes, that only. Okay. Understood?
Sir, can you scroll up, sir?
Yes. Okay.
Sir, that one, sir.
Which one?
Sir, what are we taking as reference, sir, then?
Our reference is sine omega t. Omega t is reference. Zero phase term here. Phi 1 phase
Okay.
here. Phi 2 phase here. Like that. Okay. Zero phase term is I have
Okay.
not vector in any direction, that direction, but just this line is reference line. Okay.
Yes, sir.
Right. And I will not be participating in the addition of the sinusoidal term. That will just remain as it is idle only, separately only. Now, if I have such case where if I have such case, this one, It is I naught minus I naught, and the time is t, and also this goes up to some t1 time. This is a t2 extra time. Then after that, then this is t3. I think I need to specify this one of this one. So let me take the time. Instead of giving time, I can give you the time intervals. Is it okay? This time interval. Okay, wait a second. I'm not doing that. I'm just telling you directly. I'm giving you time intervals, right? You understand what I intend to give you. This is time interval t1. This is time interval t2. This is time interval t3. This is time interval t4. This is time interval. T4 and T5 are same only. It is single sinusoidal value. T4 only time interval. Okay. Find out the RMS. Find out. Very simple way we can do it. Just simple thing you remember. If I have such terms, each acting in separate time, but they are not acting all together, then I will be having I RMS as sigma IK RMS square into TK divided by sigma TK under the root. This it will be. If you are confused with this, apply the same formula as we applied before. What? 0 to t I square dt. What it will give us? 0 to t I square dt. What would it give us?
Finally, it gives I square only.
Finally, it gives I RMS square into t, right or not? It always gives us I RMS square into t.
Sir, by t.
Huh?
By t will be there, sir, again.
It is equal to I RMS square into t. I'm saying. If it is T1, then it will be I RMS square into T1. So same way, if I take I square dt time T1 to T1 plus T2, then again I will be getting the corresponding I RMS square into time upper limit minus lower limit, that is T2 time interval. Okay. Understood? So ultimately what we are doing here, we are finding the numerator I square dt and we are putting the limit 0 to what time do we have at last? T1 plus T2 plus T3 plus T4. T1 plus T2 plus T3 plus T4, that is 0 to T1 plus T1 to T1 plus T2 plus T1 plus T2 to T1 plus T2 plus T3 plus T1 plus T2 plus T3 to T1 plus T2 plus T3 plus T4 All right. This is first current, second current, third current, and this is fourth current. First current is constant, second is linear, third is linear, fourth is this one. So what will be the values of each separate terms now? Therefore, I square into dt up to total time interval t1 to t2 plus t3 plus t4 will be finally I RMS square I1 RMS square into t1 plus I2 RMS square into t2 plus I3 RMS square into t3 and dot dot dot. Okay. Not many terms. I will write the fourth also. Plus I RMS square I4 RMS square into T4. So now just take this back here. Get the value of I RMS. Is it okay?
Sir, the I1 RMS I not.
Huh?
The I1 RMS I not.
I1 RMS will be I not only. DC for DC, RMS and AC, and R for DC means the constant current. For constant current, the RMS value and the average value and all these are same values only. Okay.
Yes, sir.
Okay, right. So we can get all this. We can get, I think, RMS values and the average values. Okay. Average value multiplied by time will give us the net charge flown through the circuit. Remember that thing also. Don't forget that. They may ask what is the charge flown. Rather than asking directly what is the average current, they may ask what is the charge flown in such time from this cross section. Then that will be nothing but the average into time. Now another. Okay, I think this is enough. I think for RMS, etc. Those values. I will ask you another question now. Just based on what I told you yesterday. This is 30 ohm. This is omega is given as 50 hertz. If not mentioned, in India we take omega to be 50 hertz. If they forgot to mention. Okay. This is it. And L is given as maybe 4 by 5 Henry. Okay. H and capacitance is given as maybe the capacitance is given as 1 by 2500 farad. Okay. Or I can say 1 by 2.5 millifarad. 1 by 2.5 millifarad. Or you just write it as 1 by 2.5 will be 10 by 4, 4 by 0.4 millifarad, right? 0.4 millifarad. That is capacitance. This is given as 100. One more thing I want to say here. If I give it 100 here, what does it mean? Which value we have given here?
V
Are you
naught
there?
by that.
It is not I naught value. When they say it is 100, Okay, I think this was important, but yesterday I forgot to tell.
V naught value, sir.
Yes, this is V naught value here. Not V naught, sorry, you are confusing. This is VRMS value here. If I mention just VR, if I mention only one value, then it is VRMS. But if I mention it is 100 sine omega t, if I mention it is 100, then it means 100 is VRMS. If I mention it is 100 sine omega t, then 100 refers to V naught. So understand the difference. How we represent it. We just write 100. It means they have already found out VRMS. But if we write in this way, then they have not written VRMS, then they have written the peak value. Okay. So very minor difference. No sin omega t term, then it is RMS value. Sin omega t term is there, then it is it. In this case, RMS value will be what? In this case, RMS value will be V naught by root 2, as we have learned the formula today, which will be 50 root 2. And in if I give in such a way, then VRMS will be 100 and V naught will be 100 root 2. Okay. So in my present example, what is 100 representing here? Tell me. VRMS. Question is, find the voltage across inductor. Find the voltage across inductor. How will you find? Just same thing as before. Only thing is, these are not numbers. These are complex numbers. Other all formula are like resistances only. The way we do for resistance. But the splitting of current also same way only. The way we do for the resistances. But only thing is, the resistance will be taken like complex number I1 and I2. So I will divide in what ratio? I will divide in the inverse ratio of, in place of resistance, it will be just complex number, complex resistance, or we can say impedance. Complex resistance is also called as just impedance, effective complex resistance. What is XL magnitude wise? Or what is XL with complex
Omega
number as a complex? XL is equal to J into omega L. What is that?
40, sir. 40.
And what is XC?
minus J by omega C.
Minus J by omega C. What is that finally?
500, sir. Minus 500.
500 it is.
Minus 500.
I did not want you to give it 500. My calculation went wrong, it seems. 0.4 milli into 50.
50, sir.
Huh? 50 only?
50 only.
0.4 million.
50.
50 only, right?
So minus 50 J.
So X, yes, right. That is minus 50 J. XC is equal to 50 into minus J. Imaginary, real. Whatever it is, what is the effective impedance in the numerator, in the upper part? And what is the effective impedance in the lower part? It is here 30 plus 40 J, and it is just 50 minus J. Do you know magnitude wise these are equal? Are these equal magnitude wise or not?
Yes, sir, equal.
Equal only. And I can tell one thing. This is, let us say I1, and this is I2. I can say I1 complex number into 30 plus 40 J is equal to this V, whatever V is, I don't know, this V. When they don't mention what is the phase of V, then we assume its phase to be a reference phase. I will take its phase to be 0. Understood? I will take it as a reference because they have otherwise also not mentioned what is its phase. So I will just write it as reference, and reference is given as 100 to us. Or not 100. Yes, 100 only. Understand one thing now. If I take it as 100 RMS value, then this also will give us RMS here. On the other hand, if I take it 100 root 2, the peak value, then here I1, which we get in after solving, will also be peak value. This will be corresponding to each other. Understood? Means I can say this thing that IRMS into Z is equal to VRMS vectorally, and not vectorally, complex number, as a complex number. And similarly, if I take I peak value into Z, then that will give us V peak value. Understood? Okay. Are you there or not?
Yes, sir.
Yes, sir.
Mhm.
Understood.
Then can you determine, what was my question? My question was, what is the value of voltage across inductor? Find VL. Okay. Find VL. Can you find it out? So VL will be nothing but, first to determine I1. I1 is equal to 100 divided by 30 plus 40J. It will be easy to do if I do it by 100. Rationalize also is not tough. If I rationalize it, I get 50 square, and here I get 30 minus 40J I1. What is that? 100 by 15, 50. 1 by 25, I think, into 30 minus 40J. That is finally divide by 5. 6 minus 8J divided by 5. That is I1. We are getting I1 value, and V we have taken as reference. Let us draw the phasor diagram. What is V value? 100 taken as reference. Where is I? I is in has this part here, and this part also, and some this part. Resultant of this, so I take, that is I. Okay. So what is it finally? This is your V and this is I. I is equal to 6 by 5 and this is minus 8. Minus 8 by 5 into J. Okay. What is this phase coming out to be between these? Can you determine this phase? Tan phi will be equal to 8 by 5 divided by 6 by 5, which is equal to 4 by 3. Therefore, phi is equal to 53 degrees.
53 degrees.
Phi is 53 degrees. Now, actually, I'm doing little more than required. Don't think that this is required for determining what? Determining VL. No, it is not required for that. That we can get now directly from here only. What is VL? VL is nothing
I1
but
bar into
I1 into
XL
omega
bar, sir.
L into J. Yes, I1 bar into
Yes,
XL
sir.
bar. I1 bar into XL bar. A bar is means this bar, not, you know why I cannot even use this symbol. This symbol signifies as if it is a conjugate of a complex number. I'm not taking conjugate here, so I'm just putting a vector symbol above it, right? Not just a single bar, but with arrows representing vector. Although it is not
Sir,
vector, it is just, yes.
I1 is a complex number only. This 1 by 5 into 6 minus 8J only. We have to write now, sir.
Yes, we have to write complex. All these are complex numbers only. Don't forget it. Even the one which is given as real, V, that is also a complex number, but it is a complex number of unknown phase. When it is unknown phase, then we assume it to be as if it is of a reference, as if it has, what is this value? I will assume its value to be 100. I will assume the current to be 100 root 2 sine omega t. I will take it as reference. I will assume its phase to be 0 degrees, unless they mention it. Okay. Therefore, I will take it like real, but it is also not real. It is also complex here. What do I get then? I1 into 1 by 5 into 6 minus 8J into omega L. Omega L was 50J, right? That is VL. What is VL coming out to be? What is VL? 50 times 10, 60 minus 80J, I think. That is VL. What is VL magnitude? VL magnitude is 100. 100?
60J plus 8%.
60J
Plus 80.
plus 80. Yes, sorry. That is right. 60J plus 80. Now, is it 100 or not?
Yes, sir, it is 100.
So, see, this is interesting now. Don't think if it is 100, then each of these will be less than that. Not. Sometimes these values comes out to be more than this also. And it is allowed here. It is allowed. Why it can be more also? For example, if I want to get this sum of 3 vectors, I know the individual vector length maybe this is big, this is also very big, this is also very big, and this is, let us say, voltage across inductor, this is voltage across capacitor. In another case, not this example, some other case, it is VL minus VC, and then let us say by adding this VL minus VC with VR, we can get resultant V. So resultant V may come out to be less than VL, less than VC. This case I am taking, by the way, for maybe series RLC circuit. This is here VL, this is here VC, and this is here VR. Okay, and this is net V. Why I'm saying this? I'm taking for series RLC. Then only I can add these. I'm adding VL with VC. What is it? It is resultant of VL and VC. What will be this thing? This thing will be VL VC, VL minus VC. They will be always in opposite phase. This resultant will be VL minus VC. And what will be V? V will be equal to VL minus VC square plus VR square under the root. Because this VR and VL minus VC, this will be at 90 degree to each other. So you notice that V may be less than VL and VC, but it can't be less than VR. Is it less than VR here? It cannot be less than VR in this particular case, right? It cannot be less than VR.
Your time completed, sir.
Okay, then I'm ending it now.
Sir, once can you
One
scroll up?
doubt.
Okay, this one.
Sir, doubt.
Sir, VL, WL is 40 now, sir.
Yes, sir. 40,
WL was
sir.
not 50. Sorry, that
No, sir,
was
40,
a
sir.
mistake.
Then
it is
VL
something
will
else.
be 80, sir.
VL will be
80 magnitude
no,
wise.
no problem. But it is not a rule. Here you may think that here it is coming out to be less than 100. Not always. Here it will be less than 100. I think so. Why? Here it will be less than 100. Now I'm noticing, because it is, let us say, some voltage here and some voltage here.
They will add up.
Then I know here VL square plus VR square, not adding up. Adding vector addition. VL square plus VL square. This is V. So in this particular example, it is true that VL is less than V. Correct only. I did not notice it before. Thanks for pointing out the mistake. So what was it here? It was 40. Then it came out to be 45, 80, 68. 68 are 48 minus, and then 8 4s are 32. 48J.
It's a 48J plus 64.
64.
5 8 48 square.
Yes, sir. 48J plus 64.
And that is 80. Correct only. Right.
Sir,
Okay. Yes.
here we have taken least value, minimum value, no, sir.
Here we have taken.
Minimum value 100
What do you mean by minimum value?
means you told peak value 100.
There is no minimum. What is this boy even talking about? What is minimum? Really? One is RMS, other is peak. We are having discussion about that. One we take RMS, other we take peak. And where is minimum in this? Minimum value is 0 always for any sinusoidal value. But what do you talk about minimum really? There is no discussion of minimum anywhere. It is not minimum, it is RMS. This 100 is here, not peak value, it is RMS value. That also I told you. This is RMS value because it is 100 only mentioned here. If I write 100 sine omega t, then it would mean that it is peak value.
Okay, sir.
What is voltage at our home? What is the voltage at our home? Tell me. What voltage supply do you get in your house? Huh? Do you know that you get 240 volts at home or not?
Yes, sir, DC.
Yes, sir.
Then this 240 volt is not DC first of all, it is AC and it is RMS value. When they say
RMS.
240 volt, then it is RMS. But if somebody is saying that you are getting 240 root 2 sine omega t, then that 240 root 2 is obviously peak, because in that he's mentioning sine omega t. But when we generally say that we have this voltage at our home, then we mean by that value is RMS value, not the peak value. Peak value is much more than this also. What is the peak value which we get at our home? That is not 240, that is 240 root 2. Okay. Understood?
Yes, sir.
Okay, then I'm ending it now.